Okay, we're on our last page of worksheet 5, numbers 23 through 26. On number 23, we have f given to us, and they tell me that g is the inverse of f. Which of the following could define g? So to find an inverse of a function, we switch the x and the y, solve for the new y. That's f's y, so we're going to switch the x and the y, solve for y. I'm going to begin by dividing both sides by 4. And now I'm going to take log base 2 of both sides to get the power by itself. So I'll have log base 2 of x over 4 is equal to y minus 3. Add 3 to both sides. And we get log base 2 of x over 4 plus 3. That is answer choice C. Okay, number 24. Function f is given by 2 log base 5 of x. Which of the following describes f? Okay, f is increasing, f is decreasing. F increases at an increasing rate, f increases at a decreasing rate. F decreases at an increasing rate, decreases at a decreasing rate. This is a throwback to a previous unit when we talked about concavity. Unit 1, we talked about concavity. Okay? Increasing and decreasing functions. If a function is increasing, it's going up. If it's decreasing, it's going down. If it's increasing at an increasing rate, the function is concave up. Increasing, increasing rate, it's concave up. Increasing at a decreasing rate, it's concave down, but still increasing, so it would look like this. Increasing, but concave down, like a frown, part of a frown. Decreasing at an increasing rate, that would look like this. We're decreasing, but we're concave up, part of a cup or part of a smile there. And then decreasing at a decreasing rate would be decreasing and concave down, so it would look like part of a frown. So the question is, which of those looks like the graph of a log function? Which of those looks like the graph of a log function? Well, hopefully you know what the basic graph of a log function is, and it does that. And we're going to be increasing at a decreasing rate. Increasing, but concave down. So answer choice B. Number 25. Which of the following could describe a single log function f? A single log function f. Okay. Well, when I first think of a log function, I think of the basic log function. The basic log function does that. And I see all of these limits here. The first one says the limit as x approaches 0 from the positive side of 0. That's what that means, from the positive side of 0. So as x approaches 0 from the positive side, so x is approaching 0 from the positive side, where is our function? Our function is down here at negative infinity. So this one tells me that as x approaches 0 from the positive side, f of x is approaching negative infinity. So there are two choices that say that. So let's continue and let's see what the other limit does. The other limits here are x is going to infinity. So let's find out which one, if one of those will work. As x goes to infinity, what is your function doing here? Your function is going to infinity, but very, very slowly. As x goes to infinity, this function is going to infinity very slowly. There's no asymptote up there. It is going to infinity, just very, very slowly. That is not one of my choices for when x was approaching 0 from the right. That is not one of my choices. That tells me that this must not be the graph of this log function that they're talking about. This is our very basic log function, but we can definitely switch that around. So let's take a look at what would happen if we flip this log function over the x-axis. You flip it over the x-axis, that means we're talking about the function that would look like f of x is equal to a negative log base something, whatever, of x. And if that was the case, the function would look like this. Okay? It would flip it over the x-axis, right? So as x goes to 0 from the positive side, now the function is approaching positive infinity. As x approaches 0 from the positive side, the function is approaching positive infinity. So now we're looking at one of these two choices. Okay, what's happening as x goes to positive infinity? As x goes to positive infinity, what is the function doing? It is getting lower and lower and lower. It's going to negative infinity. That's answer choice D. A very difficult question. Had to think through that quite a bit. And we had to use limits, which I know we're not super familiar with yet. You will be. Okay, number 26. The log function f is defined by log base 3 of x on a domain of 0 to 9, not including 0, but yes including 9. Which of the following is true? And the answer choices talk about mins and maxes. And I don't see the word local or relative, so they're talking about absolute mins and maxes. So let's graph this guy. Okay, when x cannot be 0, we have a vertical asymptote. There, that's why we didn't include 0. X cannot be 0. When x is 1, we are at 0. When x is 3, we are at 1. When x is 9, we are at 2, because 3 squared is 2. And they tell me to stop right there. So this would be the graph. We're stopping here, but we go forever down. Does this function have a maximum value? Yes, it does, and the maximum value is 2. Does the function have a minimum value? No, it does not, because it keeps going down. It's unbounded going down. So yes, it has a max, but no min. That answer choice is B.